Our project title is Lightweight Machine Learning Based Intrusion Detection System for IoT Healthcare Devices. In recent years, IoT, which is Internet of Things, has played a major role in transforming the healthcare systems. IoT devices such as ICU ventilators, patient monitoring system, wearable health sensors, vaccine cold storage units collect the data and transmit the data, and this help the doctors or the staff to make the decisions very fast and treat the patient efficiently. However, the increasing use of IoT device is also increasing the risk, which cybersecurity risk. These devices often have limited computing powers and weak built-in security, and making them uh, vulnerable for cyber attacks, such as distributed denial of service, ransomware attack, brute force attack. And these attacks can lead to data breaches, disruption of service, or even threatening situation. To address these challenges, our project focused on developing a lightweight machine learning based intrusion detection system specially for healthcare environment. And our goal is to monitor the system and behavior in real time and detect the malicious activity. In current healthcare environment, the security is mainly providing using the traditional intrusion detection system and the basic tools. These systems are classified into two types, which is hardware based and rule based. Hardware based intrusion detection system uses the firewall gateways to monitor the traffic or attack, whereas in rule based it compare the incident attack with the existing attack, so that we can come to know what type of attack. So it can't detect the unknown attack. So the limitations are it cannot detect the unknown attack, it is high of cost, and maintenance is very high, and poor scalability, and no adapting techniques is implemented in the existing system, which are traditional method. In our project, we designed specifically for IoT healthcare devices, which is lightweight machine learning based intrusion detection system. The proposed system continuously monitor the network matrices such as CPU usage, memory usage, network traffic, and disk activity, login failures, and attack type. Um, Unlike traditional method, it is software based, cost effective, and uses machine learning for adaptive learning, detect the known and unknown attack, and work efficiently for resource constrained devices. And this system is capable of detecting common attacks such as ransomware, DDoS, and brute force attack. And here is a code implementation, and generate dataset.py. Here we are generating the synthetic data, not the realistic one, like realistic but not the real one, because the hospital network data is very confidential and not publicly available. And here we are using pandas and numpy for handling the dataset and numeric values. And here we are using np.random.seed of 42 for ensuring the reproducibility, and our sample size we are giving 50,000. And here we are classifying the traffic generated, which is normal, ransomware, DDoS, and brute force attack. Here normal attack, here we are giving the range for CPU usage, memory usage, network package, disk write speed, login failures, attack type. Same for ransomware, DDoS, and brute force. To classify which type of attack. And after classifying it, we are combining and shuffling and cleaning up the code and save it into the CSV file, which is hospital IoT network log.csv. Here, this is the dataset which we are synthetically generated, and this is a PKL file. And moving on to train model.py, here uh, we are going to train the model using the random forest algorithm. And this is loaded into the CSV file, and five main categories, as I said: CPU usage, memory usage, network packet, disk write speed, and login failures. And we are importing the libraries: pandas, model selection, which is for train and test, and random forest classifier, job lib. And we are these are the features: five features: CPU usage, memory usage, network packets, disk write speed, and login failure. We are categorizing the data into two, which is x and y. Y is for target, and we are training the model, and your test size is zero point 0.2. 20% is for testing the data, and remaining 80% is for training the data, and random status is 42. And here we are using the random forest classifier model for training the model. We are using random forest classifier, and we are just dump into the job lib. And moving on to app.py, it is a real which is for simulation. And this real-time intrusion detection system dashboard using Streamlit. And this dashboard captures two types, which is this dashboard displays two type, which is live mode, and then your automated live monitoring, and then manual testing. Here we are importing the pandas, numpy, and date time for instant log. We are also implementing the incident log for detecting the suspicious activities. And the catch is for improving the performance. And here we are giving the styles and dashboard creations methods, and automated live mode. And it automatically simulates the normal and attack traffic. In manual mode, allow the user to set the parameters and control the system parameters manually. And we are also maintaining the incident log, and this incident log maintain the uh, time, status, and attack type for detecting the suspicious activity. Now moving on to the real time simulation. Now I'm running the app.py. As I said, two types of modes is given: manual mode and live monitoring mode. And in manual mode, we have the matrices like CPU usage, memory usage, network packets, disk write. We manually give some values and check for it. Now I'm giving the I'm increasing the number of failed logins, so it will be detected as brute force. It is detected as brute force by adjusting the network packets. If I give more network packets, then it is detected as distributed denial of service. Let's go for the live monitoring. Now I'm just going to start simulation. If normal behavior is detected, a green secure message is shown. If an attack is detected, a red alert is displayed with the attack details. And all events are logged with time, status, attack type, and confidence, a confidence score. This will be useful for monitoring, auditing, and forensic analysis. See, as I said, the incident ST log is given with time, status, CPU load, and disk alert type and confidence score. This is a simulation of a project and future enhancement. Although the proposed system perform efficiently, uh, some enhancement are needed to be implemented. Integration of deep learning model and deployment on real-time IoT healthcare devices, cloud-based monitoring, and inclusion of more attack categories, not only brute force, distributed denial of service, and ransomware. We include more types of attack, and real-time integration with hospital security infrastructure. And we will work on more accuracy, scalability, and adaptability. And our project is lightweight machine learning based intrusion detection system for IoT healthcare environment. The system effectively monitor the behavior and detect the cyber threats in real, and alert administrator by using the machine learning techniques and system level matrices. We propose the ideas to overcome the limitations of traditional methods. As I said, traditional